Alright, let's take a look at number 83. It says a 20-foot long ladder is leaning against a wall. So I'm going to get a picture drawn here. So we've got 20 feet, and that's not changing, so we can go ahead and label it. Leaning against a wall. So we have the wall on this side. Alright, and then the ground across the bottom. It says it's sliding down the wall at a rate of 2 feet per second. So I'm going to call this at y. So we know dy dt equals negative 2 feet per second. Alright, how fast is the bottom of the ladder moving away from the wall when the top of the ladder is at 10 feet? So we're trying to find dx dt when y equals 10. Alright, so first thing we're going to do is we're going to get a relationship between the x, y, and 20. So x squared plus y squared equals 20 squared. Take the derivative of both sides with respect to t. So I get 2x dx dt plus 2y dy dt equals 0. Alright, so we're curious about 2x dt, so I'm going to go ahead and solve for that. So dx dt equals 2y over 2x with a negative on it, dy dt. Alright, so we know dy dt all the time is negative 2. Alright, we can reduce that. So I've got y over x, the negative out front, and then I can put a negative 2 in there. Alright, now they said at the moment that this is 10. So our sides, we've got 10 squared plus x squared equals 20 squared. So 100 plus x squared equals 400. Alright, x squared equals 300. So x equals 10 root 3. Alright, so when y is 10, x is 10 root 3. Alright, so if I clean that up, I get the 10's cancel, so it's negative times a negative, which is positive, 2 over root 3. And that would be, so we need to go to a calculator at this point. So 2 over root 3, so 2 divided by second root 3, which is a 1.154. And we'll keep looking out for the tail end of that. It's 47. So our correct answer could be 1.154 or 1.155. Alright, and then we have one of those here, which is B. Alright, which was the correct answer marked on there. I hope that helps. That was number 83 that you'd sent the email about. Thanks, bye.